Welcome to today's lesson on the empirical rule. There are a lot of questions that I want to look at, but a lot of them are very, very similar. So don't feel like that this is really that long of a question. Normally questions are not this long. You can, in Unit 1, this doesn't not necessarily true in other units, but in Unit 1, you can immediately identify that a question is a empirical rule question because it will say bell shape, bell-shaped, something to that effect. Occasionally we'll use the word normal instead, which is just a special type of bell shape. Once you see that, I would recommend this. This is not always the best way to start. Sometimes it's a waste of time, but frequently is it a good way to start, is to draw a bell-shaped picture. And the one I'm drawing is very similar to the one at the bottom of page 122 in your book. I'm going to make basically one modification. And you're going to place 7 tick marks. Theoretically, they'd be equally spaced, but we know it's not going to be perfect when it's your own handwriting unless you pull out a ruler. And here's the one, well, I'll go ahead and keep it like it is in the book. I will label, I'll draw in, I always draw in dotted lines. Your book has some solid lines at these tick marks. And labeling each of these spaces. So I think I'll go sideways. So we have 34.13%. And these two in the middle. We have 13.59% in the next two. If my pen will write. And then we have 2.14%. I think I'm going to go back to sideways. And then 0.13%. And I will admit, there's one thing about the way that your book labels these that I don't like, but I don't know. I mean, I could fix it several ways, but I don't know what is the most mathematically correct way to fix it. So I'm going to leave it, but I believe in one question it will show up for us. And here's the one thing that I'm going to do that's different than in your book. Your book labels the bottom with X bars and S's or mu's and sigmas, but I'm going to put in the actual numbers. Our mean is 75. So it goes here, and then we keep adding the standard deviation of 8. So 83, 91, and 99, and then on the other side we keep subtracting 8. And putting in the numbers that actually match the question. So for part A, what percentage of scores are between 67 and 83? There are 2 ways to answer this question. There is a way that always works, but is a little bit slower. And there is a faster way, but it only works some of the time. The faster way happens to work on this first example. Note that 67 is 1 standard deviation to the left, and 83 is 1 standard deviation to the right. Because it's 1 and 1 on either side, then the empirical rule is also known as the 68, 95, 99.7 rule. So 68% falls within 1 standard deviation. So similar for part B, 59 is 2 standard deviations to the left. 91 is 2 standard deviations to the right. So 95%. And as you can guess for part C, 51 is 3 standard deviations to the left. 99 is 3 standard deviations to the right. So this is 99.7%. I'll come back and rework one of these with the slightly slower way, but the way that always works. But I won't rework all 3 of these. But those are 3 perfectly good answers. Normally you would only be asked for 1, but just to show you the variety, I wanted to do all 3. Now part D is also a between question. This time it's between 59, which is 2 standard deviations to the left, and 83, which is 1 to the right. So 2 and 1, those are not the same number. You cannot use the shortcut way, where you just figure out which of the three it is. So 59, the percentages between 59 and 83 are 13.59% plus 34.13% plus 34.13%. Those are all the percentages that are in between those two numbers that they asked me. And when we add these together, and I don't want to get out Excel, it's a little clunky doing it here, as you'll see later on, but we got $81.85, I believe, but don't hold me to that. Okay. So that is the way that always works. And to show you that it works, let's go back to part A. We were asked for the percentage of scores that are between 67 and 83. So it would be 34.13% plus 34.13%, which is 68.26%. Slightly off from what we got the first time, but definitely in the ballpark. And that's why I say it always works. I apologize for my dog making all the noises. You can also do things not just between. In part E, they're asking about scores below a 67. So for scores below a 67, you would take all of the percentages below 67. So we would have 13.59% plus 2.14% plus 0.13%, which is 15.86%, I think, again. And then very similarly, I just happened to pick this, but above 83, notice the percentages above 83 are the same three percentages we just did for below 69. Now, in all of those questions, part A through F, notice that the question said what percentage, what percentage, what percentage. Part G is asking for something different, but you're still going to start it the same way. It says how many students scored above 67, so we need to know the percentage that scored above a 67. So first off, pardon me, get back to my screen. The percentage, again, is not going to be the final answer, is going to be the sum of the probabilities above a 67. And I definitely want to pull out my calculator because that's probably a little too much for me to do in my head. And I'll come back and talk about that number in a minute and how I would accept another answer. But that's a good place to start. But again, we're not done because it didn't ask for the percentage. We wanted to know how many students. So we're going to take our percentage and convert it to a decimal. And we're going to multiply it by the number of students. We get 20 point. You can round to 2 decimal places. It is perfectly okay to have a decimal of a student, because I could rephrase that to say, how many students would you expect? In other words, I'm asking for an average, and averages don't have to be exact numbers that are possible. There are only 2 instances in this course where you will round. One you have already done, and that was with class width, and the other is not till Unit 3. Every other place, don't say, oh, it's students, I should round. You should always go to 2 decimal places or 4 decimal places as appropriate. Let's come back to this number of 84.12%. Here's the flaw in the curve that your book gives you. It would be very reasonable to say, well, that number shouldn't be 84.12, it should be 100%, because that should be the total, minus, coming back up here to part E. In part E, we said 15.86% scored below a 67. So the word we'll use later on is the complement of that would be 84.14%. And then multiply that number by 24. And again, my dog Summit says he's sorry. But that would be a different and correct way to go. But it's one of the reasons that it's so important that you show me your work, because I don't know what number to expect without seeing your work. Hopefully this was help in solving empirical rule questions. As always, if you have a question, please ask your instructor.